So we're going to just kind of go over the basics of pH. So first I want you to take your calculator and actually do this in your calculator and do log of 10. So you're going to enter log of 10. Pause and make sure you do that. And if you enter log of 10, it should give you an answer of 1. So now take log of 100, okay? Log of 100. If you're using a TI or a lot of calculators, you'll have to type a log and then like 100. Or in some older calculators, when we're in basic, you may have to put 100 and then hit the log button. And so if you do log of 100, you're going to get an answer of 2. Now try 1,000. Log of 1,000, okay? So log of 1,000, you should get an answer of 3. So now we're going to write 10 in scientific notation. 10 in scientific notation would be 1 times 10 to the first. So 10 to the first means 10 to the first power, so just 10, and it's 1 times 10 to the first. Okay, just a side note, if I was like, let's say 200, 200 would be 2, I should actually have done 20, 2 times 10 squared, because if I look here, 100 in scientific notation would be 1 times 10 squared. Okay, so since it's this like on the 100, since that's a 1, that's where this 1 comes from. And it's 10 squared because this is those 2 zeros times 100. And so here, 200 is 2, that's where this 2 comes from, and then the 2 zeros is that there. If you did log of 200, you're going to get an answer that's a little bit messier than just a straight 2. Okay, it's going to be a little bit over 2. Now I'm going to do, but we're going to keep it simple. So we're going to do log of 1,000, or I'm sorry, not log of 1,000, but in scientific notation, 1,000 would be written as 1 times 10 to the third. Pretty much all the problems we're going to do and we're going to see on the AP test are going to be like these, where there are 10 to the first, 10 to the second, 10 to the third, and we're not going to have this other number in front here, so we can just kind of ignore that. As you can see, though, the log is the exponent. So here, log of 10, it's that exponent, 1. Log of 100, so is this exponent here, that 2. And then log of 1,000 is the exponent there. Okay, so as you can see, the log is the exponent. So when using a log scale, a change in the log scale of 1 is really by a factor of 10. What I mean by that? To go from 10 to 100, I don't move by 1, I don't multiply by 1, I'm going to do 10 times 10 is going to give me this 100. So this is why we say it's a factor of 10, okay? I always think of it in terms of money. I'd rather have $100 than $10. It's 10 times more. So we're going to now shift to the pH scale. If we write 0.1 in scientific notation, we get 10 to the minus 1. So if you take the log of that, so take a moment and in your calculator type log of 10 to the minus 1. You may have to use the carets or different functionality on your calculator. And log of 10 to the minus 1, you should get negative 1. Or, and again, you could just do log, if you wanted in your calculator, of 0.1. If you do log of 0.1, you should also get negative 1. If we do the same of this number here, 0.001, in scientific notation, that's 10 to the minus 3. I'm just ignoring that 1 times. But again, you don't have to. You could include that. Because it's 1, that's why I can ignore it. And if you take the log of 10 to the minus 3, you're going to get negative 3. So that is kind of how all this works. But now, here's the big formula. The formula for pH is the negative log. So what I'm going to do is I'm going to look down here if I take my answer from above. So if I take the log of 10 to the minus 1, I'm going to get negative 1. And then since it's this negative log here, this negative sign right there, I'm going to take the negative of negative 1, which is going to give me positive 1. So the pH, which is the hydrogen ion concentration, that's what that H plus in here is 1. So this pH of 1 is going to be that. Versus if I take the log, like up here, of 10 to the minus 3, I'm going to get a positive 3 because it's the negative log. And so the pH of the hydrogen ion concentration then of this 10 to the minus 3, or 0.001, would be 3. So that's kind of the background of it. And again, this big idea, it's this factor of 10 difference, okay? So pH scale, okay, things are this changing of this factor of 10. So let's go ahead and let's look here. It says, finally think about 10 cents versus a penny. Which is bigger? Well, 10 cents is bigger, okay? 10 cents is bigger. So if I did the negative log, so if I'm going to do the log or the negative log of 0.1, I'm going to get for this one, for this here, I'm going to get the, if I do the negative log of it, I'm going to get 1. For here, I'm going to do the negative log, so I'll change my color again here. If I'm going to do the log of 0.01, I get negative 2, but since it's the negative log of it, this is going to give me 2. So, which is bigger? 10 cents is bigger, but it gave me a lower pH. So, since it's a negative log for pH, the lower the pH, the greater the hydrogen ion concentration, which means the more acidic the solution. Okay, so this in bold here is our big takeaway with pH, and then just being able to solve some very, very basic pH problems. And again, this idea of pH scale. Why does this matter? Where do we see, or where have we seen pH? We've seen pH with ocean acidification, and so how seashells can start dissolving, how it can shift out of the range of tolerance for specialists. Again, so it relates to climate change. In soils and in agriculture, it relates, because if the soils become too acidic, the plants can't take up the nutrients they need. And so farmers will adjust that. How will they adjust that? They will, typically they'll add lime, which is called calcium hydroxide, not lemons and limes, but like calcium hydroxide, which is a base, which will help raise the pH. So we'll see that in soils. And then in acid rain. In acid rain, the sulfur oxides, or the sulfur dioxide and the nitrogen oxides, react in the air and form strong acids. They form that nitric acid, which is a strong acid, the HNO3, and the HNO3, and the sulfuric is H2SO4. Those strong acids, again, those are secondary air pollutants formed in the air when these gases interact with water in the air. And again, those can lead to, go into acid rain, your human health, environmental, and economic consequences. So this is just a quick overview of pH. The next page does a little bit more of pH, but this is, again, pH in the log scale. Hope that was helpful.